When we talk about artificial intelligence in 2025, the conversation usually centers on how much cheaper it is becoming. We hear that the price of intelligence is dropping. We hear that democratization is happening. But there is a hidden cost that rarely makes it into the headlines. It is not about the price of a single token anymore. It is about the architecture of the work itself. The costs of AI agents are rising exponentially, but not in the way you might expect. To understand this, we have to separate the cost of building the model from the cost of running it. Training a frontier model is like building a massive factory. That cost is indeed rising exponentially. Estimates suggest training costs are growing by a factor of 2.4 times every single year. By 2027, a single training run could exceed $1 billion. This is a massive barrier to entry. However, the real story for most users is not in the construction of the factory, but in the daily operations. This is where the divergence happens. While the unit cost of executing an AI agent has dropped in benchmarks, the absolute price of running frontier models is increasing. Some reports indicate a rise of 3 times to 18 times yearly. This means that even if the model is more efficient, the complexity of the task is driving the bill up. This is driven by something called dynamic reasoning. In the past, a query was simple. You asked a question, and the model gave an answer. Today, agents think before they speak. They plan, they execute steps, they verify their own work. Consider the energy consumption. A single query involving dynamic reasoning can consume 10 times the energy of a standard web search. Think of a web search as flipping a light switch. It is instant and cheap. Now think of an agent loop as running a factory assembly line for an hour. It consumes power continuously. This is the difference between a static response and dynamic reasoning. This is because the agent is not just retrieving information. It is simulating a workflow. It might write code, run it, check for errors, and then try again. Each of those steps requires computation. Each of those steps adds to the token count. This is where the exponential rise comes from. It is not just one call to the model. It is a loop of calls. This leads to the problem of context window bloat. As agents work through multi-step tasks, they must remember what they did previously. They need to store the history of their reasoning in their working memory. This is often handled by the context window. As the window grows larger to accommodate this history, the computational load increases non-linearly. It is like trying to hold a conversation while simultaneously reading a library. The more you read, the more brain power you need to maintain the connection. In technical terms, this is test time scaling. The more you ask the model to do during the inference phase, the more expensive it gets. Here is the thing. Many developers are optimizing for speed and cost without realizing the trap. They build agent loops that are not optimized for token consumption. If you have a loop that runs 10 times for a single user request, you have just multiplied your cost by 10. Without strict monitoring and memory management, these loops can rapidly erode profitability. This is why adoption of cost optimization strategies is becoming a prerequisite for viability. Techniques like retrieval augmented generation help reduce the need to store everything in the context window. But even with these tools, the fundamental architecture of reasoning is still expensive. The market is beginning to bifurcate because of this. We are seeing a split between two types of AI agents. On one side, you have inexpensive, specialized agents. These are designed for entry-level roles where the tasks are deterministic and narrow. A bot that answers customer support questions using a fixed set of rules and limited search. These are becoming cheap. On the other side, you have high-margin, complex multi-agent systems. These are designed for deep reasoning, coding, or complex analysis. These face thin margins because the inference costs are so massive. This creates a paradox. The cost of automation is becoming democratized. You can buy a cheap agent for almost anything. But the cost of high-level intelligence is rising faster than performance gains. This means that only well-funded entities can afford high-scale AI development. The academic consensus suggests that current agent architectures are not sustainable long-term. As costs rise faster than performance gains, a paradigm shift toward compute-efficient reasoning is deemed necessary. Future economic models suggest a shift from subscription-based access to usage-based pricing. This means you will pay directly for the computational intensity of the reasoning. This makes cheap agents a reality only for narrow, deterministic tasks. If you want an agent that can reason dynamically, you will pay a premium that reflects the energy and compute required. This is the reality of 2025. While benchmarking suggests democratization, the actual trajectory points toward a future where only well-funded entities can afford high-scale AI development. So, when you hear that AI is getting cheaper, you must ask what kind of AI you are talking about. If you are talking about a chatbot that answers simple questions, yes, the price is falling. But if you are talking about an autonomous agent that plans, reasons, and executes complex workflows, the price is rising exponentially. The infrastructure required to support this is becoming unsustainable without significant architectural changes. We are at a point where the efficiency gains in hardware are being outpaced by the complexity of the software. This brings us back to the core question of sustainability. If the cost of dynamic reasoning continues to climb, we will see a shift in how these systems are designed. We will likely see more reliance on specialized models for specific steps rather than one giant model doing everything. We will see more emphasis on memory management and token efficiency. The era of infinite context windows at infinite cost is ending. The future belongs to those who can reason efficiently, not just those who can reason deeply. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.